Okay, nerds. Let's go ahead and finish up Unit 3.3 today. It's a short lesson, pretty easy stuff. We've pretty much already talked about everything that I'm going to show you today. The one thing that I do want to mention, though, is we can use trigonometry to write any x comma y that we want to in forms of sine, cosine, theta, and radius. So we have a way of converting x's and y's to trigonometries for any xy in the xy plane. Cool beans? Now we've already talked about this yesterday, and I think even the day before that, that x squared plus y squared equals r squared. That's just the equation of a circle that's centered at the origin. And this is just what you get if you take the square root of both sides, whatever. It's not something you have to memorize. As long as you know that x squared plus y squared is r squared, you're set. You're good to go. Okay? Okay. So we take this image over here, and we write some stuff that we already know to be true. How do I find sine of theta? What letters does it use? Y over r. Good. So sine of theta is going to give me y over r. So we've got a y here, and we've got an x here. So sine of theta is y over r. And cosine of theta then, you guys can just shout it out. X over r, good. And the last one, tangent theta, lots of voices, come on now. Y over x, good, 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 y over x, awesome. Okay, so these two are the key to writing any x comma y in terms of trigonometry, simply by isolating x and isolating y. What would I have to do to get x by itself here? Yeah. So what'd you say? Multiply by what? R. Yeah. If we multiply both sides by r here, what we get is that every x on the xy plane can be represented by saying r cosine of theta. And using that same bit of logic, every y value on the xy plane, multiply both sides by r, and you'll get r sine theta. So this point up here, which did have an x and a y coordinate, could have been represented by r cosine theta, comma r sine theta. You just need to know r and theta. Ta-da! Pretty cool, huh? Bless you. Okay, great. So let's just say the question had said, you know, okay, we've got an angle at 4 pi over 3. Let's draw ourselves a reference triangle and do some trigonometry there. I mean, at 4 pi over 3, could we find sine and cosine without too major of a hiccup? What do you mean, no? Jack. No, of course we could. Hardest part about this is, do you know where 4 pi over 3 is? Which quadrant is that? That's the hardest part. This is the third quadrant because it's just a little bit more than 1 pi. Remember, because 4 over 3 is 1 1/3 pies. So I'm going to draw that in quadrant 3. Don't worry about this. We'll get to this. So we've drawn it in quadrant 3. This is our 4 pi over 3. But because it says a pi over 3, I need to know what is the reference angle. Well, 180 is pi, and 180 over 3 is 60. So this is a 60-degree reference angle down here in quadrant 3. Again, I know that because it says over 3. A pi over 3, no matter what, it could have been 5 pi over 3, 17 pi over 3, 38 pi over 3, it doesn't matter. Anytime you see a pi over 3, that is going to be a 60-degree reference angle somewhere. And we already know that it's in quadrant 3 because it's 1 1/3. Here's 1 pi, 1/3 pi. So we put our 60-degree angle there. And what we're going to do now is we're going to fill out our classic 30, 60, 90 triangle side lengths. What kind of side length is always found across from a 60-degree angle? A root 3. So I'm going to put a root 3 on here. And what would this side length be? A 1 then. And what would this thing's hypotenuse be? 2. And before I go any further, what's wrong? Negatives. I'm in quadrant 3. My x and my y have to both be negative. There. This is going to give me the ability to find sine and cosine of 4 pi over 3. This right here, because I don't have the unit circle memorized. Okay? Actually, let's do cosine first. The radius is never negative because radius is a distance from the center. And because we have to say square root of something, we can't get a negative number out of this square root. So using this reference triangle, what is cosine at 4 pi over 3? Negative 1 over 2. It's x over r of the reference triangle. Of the reference triangle, x over r. So I'm not saying the radius of the circle that I'm working with. We haven't even read ahead for that, which is what's going on over here. I'm just drawing a 30, 60, 90 right triangle so I can evaluate cosine at 4 pi over 3. And what is sine at 4 pi over 3? Well, you go to the reference triangle and you do y over r of the reference triangle. Negative root 3 over 2. Great. Now we can read ahead. We're in a circle with a radius of 5. Oh! The radius is never negative, correct, because it's a distance from the center. So what we're actually dealing with here is a 30, 60, 90 triangle where the radius is 5, not 2. And I'm not trying to mess around with all of the ratios and try to figure that out. Instead, I would rather draw a reference triangle, evaluate my trigonometry, and then know that every coordinate is r cosine theta, r sine theta. Every coordinate is going to be r cosine theta, comma, r sine theta. We know cosine and sine of our theta, and we know our r is 5. So the coordinates at this point in the circle with a radius of 5 are x equals 5 times cosine theta, which is negative 1/2, and y equals 5 times the sine of theta, which was negative root 3 over 2. So our coordinate, let's just call it point P. Why not call it point P? Our coordinates are negative 5 over 2, comma, negative 5 root 3 over 2. Once again, I drew a reference triangle at 4 pi over 3. I evaluated cosine and sine using my reference triangle because I don't have my unit circle memorized. I know that every coordinate in xy space can be written as r cosine theta, r sine theta. R was given to me as 5. So r cosine theta, r sine theta. There it is. If you plot this point, you will find that it is exactly 5 away from the origin and 60 degrees below the x-axis. There it is. Do you have questions about it? I see a lot of just people just kind of looking at it. Which generally means they're trying to think their way through something. And I would like to help wherever I can. Stunned silence. Isabel, you look like you're on the verge of asking a question.
Okay, so we have to figure out the sine cosine.
At the reference angle, yes.
As if it was the unit circle.
Well, as if it was the unit circle, yeah.
And then we gotta take it to the actual thing, and that's where radius 5 comes from.
Exactly. So the coordinate on that unit circle that I didn't fill out. But if we'd filled it out, at this angle, the unit circle coordinate is negative 1/2, comma, negative root 3 over 2. But that's a circle of radius 1 unit. So if you want a circle of radius 5 units, since they're similar figures, you just multiply by 5. So you would have taken this coordinate off the unit circle and multiplied it by 5. And it'll get you to there. Okay? But I don't have that unit circle memorized, so I always do this. Yes? I did not convert 4 pi over 3 to degrees. That's too much work. What I did was I said, realize that this is a little bit more than 1 pi. Here's 1 pi. So it's literally 1 and 1/3 of a pi. So you go past 1 pi. This is 1.5 pi. 1 1/3 is less than 1.5. So I drew my triangle. And then I said, what are my subdivisions of pi's? Oh, thirds. And a third of a pi is 60 degrees. So I know it's a 60-degree reference angle. In my reference triangles, I'm always going to put degrees. That's just because, honestly, it's because a fraction would require more vertical space than a number with a degree symbol. That's literally why I don't use the radians. But what do you say? It's 60. It's 240 degrees. I just did 180 plus 60, but I just now converted it. So I just said 1 and 1/3. Okay, go past 1, but before 1/2. Oh, and over 3, that's 60 degrees. That's how I do it. Alrighty. We have an angle that is in quadrant 2, and we're told that cosine is negative 1/3. Our job is to figure out what sine equals there. Close off our triangle. Cosine is the letters x over r. Remember, r is always positive. That tells me my x value was negative 1. My r was 3. In quadrant 2, my y value will be positive. X squared plus y squared equals r squared. Please use parentheses. So y squared is 8. Take the square root of both sides. I showed it in period 2, so I'll show it here too. Square root of 8 is square root of 4 times 2, which is 2 root 2. I think solving for y was the hardest part of the question. Sine just says y over r. Your y value you just found, 2 root 2. And r was handed to you. Done. What do you think? Noah, you looked like you were about to ask a question. What do you think? Sure? Okay. Alrighty. Then if there are no questions, we'll move on to number 8. It says find all the angles in the first 2 pi where r cosine theta would be equal to 0. Can r be 0? If you have a radius of 0? No. If you have a radius of 0, you're literally at the origin. You don't have a triangle. So what is the only way that r cosine theta could be 0? Is if cosine is 0, which means x is 0. And the reason why we know that is because instead of saying r cosine theta, we could have said r times whatever cosine equals, which is x over r. So the r's cancel, and you're left with when x is 0. That doesn't mean the answer is 0. That just tells us we have to look for the angles where x is 0. So where on the xy axis is x 0? At the 90 degrees which is half pi's and 1.5 pi's. It's the y-axis. It's the y-axis. If you are here on the y-axis or here on the y-axis, x is 0. This angle is pi over 2, 90 degrees. But we have to answer in radians because the domain in the written question was radians. And down here at 3 pi over 2. So those are our two answers. When theta equals pi over 2 and 3 pi over 2. There it is. If it had said our sine of theta is 0, then we would have needed y to be 0, which means we'd have been on the x-axis at 0 and pi. We would not include 2 pi though because no equal to bar. Congratulations, you solved your first trig equation. One of many. One of many. We're going to do logarithmic, quadratic, trigonometric equations, all kinds of fun stuff. Yeah. I can't wait either. I freaking love trig. I love trig. Trig. Okay. You guys cool with that question? Notice it doesn't matter the size of the circle. If you're on the y-axis, x is 0. Okay. These, I've always enjoyed these kinds of questions because they feel like a miniature scavenger hunt. First things first, you're told that tangent is positive. In which two quadrants can I find tangent to be positive? 1, where everything is positive, and 3, where x and y are both negative, which makes tangent positive. So if I had no other information, I would have to draw that triangle in 2 places, once in quadrant 1 and once in quadrant 3. But I have more knowledge. Cosine is negative. So when is cosine negative? Not what quadrant, but when? When x is negative. And since we're saying cosine is negative when x is negative, which 2 quadrants have negative x? 2 and 3. So all we have to do is pick the one quadrant that works for both situations. Quadrant 3 it is. So we're going to draw our triangle in quadrant 3. We were given tangent. Tangent is y over x. But because I'm in quadrant 3, both x and y are negative. And you must remember that. Alrighty. Our question has tasked us with finding sine and cosine of our theta. Both of those require the radius. How can I get it? I know x, I know y. Pythagorean theorem, x squared plus y squared equals r squared. What would be great is if you recognized instantly what the radius has to be without doing any work. 5. This is a 3, 4, 5 right triangle. It's called a Pythagorean triple. Two Pythagorean triples are remarkably, insanely common because they require no calculator to use. One of them is 3, 4, 5 and any multiple of 3, 4, 5. It's all over the SAT. The other one would be the 5, 12, 13. Also all over the SAT. You'd be amazed how often you see a 6, 8, 10 on the SAT. That's a 3, 4, 5 times 2. Shows up all the time. All the time. Anywho, our theta is actually here. Boink. So we're just going to find sine and cosine of that theta. Sine, y over r. Negative 4 over 5. Cosine, x over r. Negative 3 over 5. And that's it. I mean, the hardest part is figuring out where to draw this triangle. If you know your X, Y, R stuff. Talk to me. If you got questions, hints of questions, whispering of a question, let me hear it. Let me help. A Pythagorean triple is it's a set of 3 numbers that make a right triangle without any decimals. Like 3, 4, and 5. That is a right triangle, and there's no decimals. It's like you're looking at me like you don't catch what you sort of get it. Well, I don't want to write on the back of my nerd paper. Here's some paper right here. Okay. 3 squared is 9, 4 squared is 16. 9 and 16 makes 25. So 3 squared plus 4 squared equals 5 squared. And you could multiply that by any number you want, and it will still hold true. This is called a Pythagorean triple. 5, 12, 13 is another one. 5 squared plus 12 squared equals 13 squared. They're just whole number right triangles. And then there's 7, 24, 25, where 7 squared plus 24 squared is 25 squared. There's one in between that I always forget. It's got a 19 or a 17 in it. I can never remember it. And the reason why I don't remember it is because you don't see it all that often. These 3, super common. Those 2, have you taken the SAT yet? When you take it, you will see one of them on it. Now, it might not say 3, 4, 5. It'll probably say 6, 8, 10. Or it might not say 5, 12, 13. It might say 10, 24, 26. But if you recognize them, they're going to make you much faster, and you don't need a calculator. So, those are called Pythagorean triples. And lastly, we're going to use a calculator for this one. A machine shop needs to drill a hole through a plate of steel. They want to draw it right there. They know that the radius is going to be 14. They know that the angle is 25 degrees. We are going to figure out what the coordinates of point P are using trig. Every coordinate in the xy plane is r cosine theta times r sine theta. Did I say times? Comma. R cosine theta, comma, r sine theta. So we already know r, it's 14. And we know theta, it's 25 degrees. So just fill it out. The coordinates of our point are 14 cosine of 25 degrees, comma, 14 sine of 25 degrees. There it is. That's the perfect answer. The radius and the trig? Yeah, but you don't have to put a dot there if you don't, I mean, it's like saying 14x. And then it says, use your calculator to approximate the location. That means type 14 cosine of 25 and 14 sine of 25 on your calculator. That's what that means. So let's get it. 14 cosine of 25 equals, and 14 sine of 25 equals. This is quadrant 1, correct? Look at my answer. That's not quadrant 1. Negative y. What happened? What went wrong? My favorite one, someone's, oh, my calculator's not working right. No, it's you. What went wrong? Do you see it? What is it, Charlie? My calculator's in radian mode. These are degrees. You need to change it to degree mode. Press mode. Come on down over to degrees. Now, 14 cosine and 14 sine of 25. Yes? Because most trig is done in radians. You have to change it back and forth. Yep. So whatever the question is asked in, whatever unit the question is asked in, that is the unit you work in on the calculator. There. So the approximate answers, oh, wah, are 12.7 comma, oh wait, 3 decimals. This is AP, not IB. 12.688. Sorry. It's hard to transition between the two. Comma 5.917. There we go. So he's boo-hooing back there. Oh, it's too much work to have to swap back and forth. Wah. Okay. All right, I tell you what. Let me show you a way that could make it so that you can work in radian mode almost all the time. We put my calculator back in radian mode. I need to tell it 14 cosine of 25 degrees, right? 14 cosine 25. See right there above apps? In blue it says angle. Second, angle. Look at the menu it brings up. The very first symbol is a degree symbol. And now, even though it's in radian mode, it knows that that's 25 degrees, and the answer is 12.688, like it should have been. So you could do it that way. Now, that is not to say that you still won't have to move back and forth. You will. There will be times when you need to be able to work in one unit over the other. But if you'd like to keep it in radian mode and just type the degree symbol most of the time, you can. Just make sure you don't forget. Don't forget. That's it for the lesson. What do you guys think? Pretty easy, right? Yay. Thanks, trig nerds. Appreciate you.